In this video, we're going to go over how to identify the difference between an arithmetic and a geometric sequence. They're going to give you a sequence of numbers like 2, 4, 6, 8, 5, 10, 15, 20, and you need to identify whether it's an arithmetic sequence or a geometric sequence. So let's look at the definition of an arithmetic sequence. For it to be an arithmetic sequence, the difference between the consecutive terms has to be constant. That means you are adding or subtracting the same number. The important words in this definition are constant and difference. So we're going to look at this sequence of numbers and we're going to determine that it's going to be an arithmetic sequence. Here's how you determine that. You're going to take the next term, and difference means subtract. You're going to subtract it. So we're going to take 38 minus 44 and find the difference between these. We're going to do the exact same with the next term. We're going to go 32 minus 38. And then we're going to go 26 minus 32 and see if we're getting the same number every single time. So with my calculator, remember I'm going to take the difference between these two. I want to take the second one and subtract it from the first one. 38 minus 44. The difference between these, -6. I'm subtracting 6 because I'm going down. I need to find the difference between these two. I seem to be subtracting the same number every single time. Let's try it again. This is an arithmetic sequence. I'm subtracting the same number every single time. That way I can find what the next number in the sequence is and the one after that, because there is a constant number, the same number, being subtracted every single time. And remember, you can add numbers, you can subtract numbers. The difference means that's how you find whether or not you're adding or subtracting numbers. In a geometric sequence, again, it has to be constant, the number, and you need to find the multiplier between each consecutive term. That means you're going to be multiplying or dividing by the exact same number. So we're going to find out whether or not this is a geometric sequence. To find whether or not it's a geometric sequence, I take this number and divide it by this one. This is going to be 10 divided by 1. 10 divided by 1 is 10. I'm multiplying this by 10. Let's see if it works between these terms. I'm going to take 100 divided by 10. 100 divided by 10, I'm still multiplying by 10. I need to see if it's going to work between these two terms. 1,000 divided by 100. 1,000 divided by 100, I'm still multiplying by 10. So, for it to be a geometric sequence, you have to be multiplying by the same number or dividing by the same number. For it to be an arithmetic sequence, you have to be adding or subtracting by the same number. So let's look at some examples. We're going to determine whether or not this sequence of numbers is arithmetic sequence or geometric sequence. First thing I need to find is the difference between these. And once I find the difference, I'm going to see whether or not it's the same number, whether or not it's constant. That means I need to take 121 and subtract 131. 121 minus 131, I'm subtracting 10. Let's see if it continues with the difference between these two terms. 111 minus 121, I'm subtracting 10. Check it one more time. Between these two terms, minus 10. Is this an arithmetic sequence? Yes, it is. It could also be a geometric sequence, so I need to check that. I need to divide these two numbers. I need to take 121 and divide it by 131. 0.92. I'm multiplying by 0.92. When I check between these, it better be the same. When I take 111 divided by 121, I better get 0.92. .91. I'm not getting the exact same multiplier every single time. So is it a geometric sequence? No, it's not. It's just an arithmetic sequence. Our next example, we're going to determine whether it's an arithmetic or geometric sequence. I need to check for both because it could be both. To figure out if it's an arithmetic sequence, I need to find the difference. I need to take negative 93 and subtract 31. Negative 93 minus 31 minus 124. I need to subtract these two and see if I get the exact same difference. And remember, it's minus a negative 93. I am not getting the same number as the difference between these. Is this an arithmetic sequence? No, it is not. I need to check and see if it's a geometric sequence. I need to take these two and divide them. That's going to be negative 93 divided by 31. I'm multiplying by negative 3. I need to see if I'm multiplying by negative 3 between these two. That means I'm going to take 279 and divide it by negative 93. It's showing I'm multiplying by negative 3. Is this a geometric sequence? Yes, it's a geometric sequence because I'm multiplying by the same number. I'm not adding or subtracting by the same number, but I'm multiplying by the same number. So that means it's a geometric sequence. I need to check if this is an arithmetic sequence or geometric sequence. First thing I need to do is check the difference between these terms and see if I get the exact same number. That means I'm going to take 64 minus 32. I'm adding 32. I need to see if that's the same number between these. That means I'm going to take 192 and subtract 64. I get 128. So is it an arithmetic sequence? No, I'm not getting the same number. I'm not getting the same difference. I need to check if it's a geometric sequence. That means I'm going to take 64 and I'm going to divide 32. I'm multiplying by 2. Let's see if I get the same multiplier in between these. That's 192 divided by 64. I'm getting a multiplier of 3. Is it a geometric sequence? It's not a geometric sequence either. It's neither, because I'm not getting a constant number in between as far as the difference, and I'm not getting a constant number in between for the multiplier. I need to check if this sequence of numbers is an arithmetic sequence or a geometric sequence. I need to see if I'm adding or subtracting the same number. I'm adding 0 every single time. Is it an arithmetic sequence? Yes. To get my geometric sequence, or see if it is, I'm going to take these two and divide it. I'm multiplying by 1. 93 divided by 93, I'm multiplying by 1. Is it a geometric sequence? Yes, it is. It's both. It's both an arithmetic sequence and a geometric sequence. If they give you a word problem, you're simply going to write down the sequence and determine, like the others, whether or not it's arithmetic or geometric. Chad is sorting pencils into boxes. He puts this many pencils in the first box, this many pencils in the second box, this many pencils in the third box, this many pencils in the fourth box. So what we're going to do is we're simply going to write those numbers down in a sequence: 125, 106, 87, 68, and we're going to go through our process checking for arithmetic sequence or geometric sequence. I need to check if I've got the same difference between these numbers. 106 minus 125, I'm subtracting 19. I better be subtracting 19 for this to be an arithmetic sequence. That means I take 87 and subtract 106. Minus 19. It is an arithmetic sequence. I need to check and see if it's also a geometric sequence. That means I'm going to take 106 and divide it by 125. .848. I better get the exact same thing when I divide 87 by 106. Times 0.82. It is not a geometric sequence because I'm not multiplying by a constant number. I am subtracting a constant number, so it's arithmetic. When they give you word problems where they don't actually give you the sequence of numbers, you need to read the problem and determine whether or not it's arithmetic or geometric. Remember, arithmetic, you have to be constantly adding the same number every single time. For it to be geometric, you have to be multiplying the exact same number every single time. So, due to the population boom, a mall is able to attract 7 times as many visitors each year as it did the year before. If you list the number of visitors over time, what kind of sequence will you see? Well, if you're multiplying it, it's going to be geometric because it's 7 times as many. That means if I have 7, then the next one's going to be 49, then 49 times 7, and so forth and so on. So as soon as it says 7 times, it's going to be a geometric sequence. The next one, Mitch goes to the gym 1 time per week. If you track the total number of gym visits he has taken over time, what kind of sequence will you see? Mitch goes to the gym 1 time per week, and you track the total number of gym visits. The total number of gym visits, that means the first week. Second week, what's the total? Third week, what's the total? Fourth week, what's the total? You are adding 1 every single time. If you take these numbers and divide it, and these numbers and divide it, you're not going to get the exact same multiplier. Then this is going to be arithmetic. Lacey's family goes on vacation 3 to 5 times per year, depending on how often they can coordinate their schedules. If she writes down a list with the number of vacations she has taken every year for the past 10 years, what kind of sequence will she see? Well, since it's not consistent, and all these others have to be consistent, whether it's geometric or arithmetic, the number has to be consistent. Since this is not a consistent number, it's not going to be geometric and it's not going to be arithmetic. And as soon as it shows that the numbers are not consistent, it's going to be neither.